Uh-oh. Test.
Yeah. Yep.
Okay. Yeah, I think Aladdin is really heavy, and so I think that maybe
Yeah,
I'll
it's really
skip
heavy.
that. Yeah, all right. So
Yeah, it's
people
really
can play
heavy.
with that. It's people can try that out for themselves, I guess. Yeah, all right. Let's see, what else do I have? I guess.
Also, the Topcat
Hmm.
for playing with the catalog data.
Yeah, Topcat. I have barely played with. Um, I do have it. So yeah, Topcat is a tool for, as you said, basically for dealing with catalog data and manipulating it. Let's see. Do I have? Problem is, I've barely used it, so I'm not sure I feel confident to show it off. Trying to
But there
think.
is one another great feature that there is a uh, SMAP protocol where you can load up Topcat and Aladdin and then select the data and transfer it over Aladdin using this
Mhm.
SMAP protocol.
Yeah. So you can do that, and it's also really good for accessing catalogs online using the same protocol. Let me just
Yep.
see if I can load up. I have a local table. Yeah, so that one's looks like it's loaded. Let me just see if there's an easy way to. Nope, not that one. To load up remote data. So yeah, there's oh yeah. So you can access Vizier. Do I have access to? Yeah, so I do know where there's some interesting data I can show off, but I don't remember what server it's sitting on. So, anyways, that's a shame. This is just Vizier. Yeah, it has access to the Vizier ones. So yeah, there is a super secret server I could show off, but I lost track of where it is, and I'm not going to go dig it out. But yeah, basically, yeah, Topcat is just a nice tool for looking at table data. So yeah, so this is the catalog from my paper that I showed off. Positions, polarization data, et cetera, et cetera. And in principle, you can do some neat things like plane plot. And so you can just tell it to plot various things. So I'm plotting RA index. This is position and sky coordinates. I could change this to plot galactic coordinates of all the sources in my catalog. And so you can see, yeah, in galactic coordinates, it's a nice, well-structured chunk of sky. And so yeah, you can basically explore data sets in a very quick and easy way with this. And so if we want to compare, let's compare. So one that would be physically interesting to some degree is rotation measure error, which no one will particularly care. But no, okay, that one's not working. But anyways, there are sort of different different ways you can explore the data here in order to see if any interesting trends pop out, or to try to understand. So that's the one I was trying to achieve. This is a relationship in which we basically expect these quantities to have kind of a 1/x relationship, and so you can kind of see
Okay.
that
Yeah.
on these axes. I wonder, is it possible to do logarithmic axes on these? I actually don't know.
Yeah. Go to
That's
the
probably.
axis on the left hand side.
Uh, oh yeah, here. Here we go. Excellent. Yeah, there we go. So yeah, on a log scale, we immediately get our sort of 1/x relationship. And so yeah, I don't use this a whole lot because I'll confess I prefer to just load stuff up into Python and play with it that way. I find it more
Yeah, it's
intuitive
just
and
to
more
get the feel
powerful.
of the table, to be honest.
Yeah.
You can do
Yeah.
basic linear fitting and all, but nothing beyond that as
Yeah.
far as
I
I
think
know.
to my mind the most powerful aspect of this is just the ability to go online. To be able to go to Vizier without even having to download a table. Um, and
Yeah, you can
yeah,
even write SQL script to get the data as well. There's a tab thing, table
Okay.
access protocol.
Yeah.
Where
Yeah, I've played a
like
little bit with
I
that,
have
but
attached a PDF in Whiteboard, like which got me started into Astro. So there it talks about this DS9 and Topcat, like how to
okay.
write scripts and all. It's really nice.
Yeah. Yeah, there's a lot of really good things you can do. And yeah, I mean, I'll confess, just as I said, I've not played with these particular tools as much as you have, I think. But
Uh,
yeah, it's
yeah,
pretty easy to
I
get
have
into.
done. Yeah, yeah.
Yeah. All right. Have I got anything else that's super interesting? I don't know. Yeah, I mean, it's not necessarily astronomy related, but if you do get into like research or big projects, it's good to take notes. And so I have this is a program I use called Evernote, which is available for free and paid. I think I technically have paid for it, but it's a nice, easy way to sort of make notes and keep them organized. And so it's super useful for like if you're working on a project and you want to keep track of uh, things that you have going on. So let me see how much is in here. So this is not a great example because I'm very disorganized. I tend to have notes in like three different places. And so this
There's
is I
one
took some
another
notes from.
interesting app called Obsidian where you can link up notes. It's
Hmm.
really nice.
Yeah. There's a lot of different packages for or different software for doing this. This is just one that I happen to use. But having something that you can keep notes in, like paste images in, short sections of code or something, things like that is super useful once you start getting involved in bigger projects. Just to keep track of, just to keep track of what you're doing, really. And I'm not as consistent as I should be, but yeah, I mean, it's trying to think if I have anything useful to show here. Things like I keep like a little diary of what I do every day, just a couple of short notes every day. I'm trying to find some that aren't sensitive, I guess, but it's like notes about like okay, I need to email somebody, or I fix something in some data, and this is not my full notes, but this is just my diary, so I can look back and it's like when did I do this particular thing, kind of a problem. Um, or like I've had student projects, and I'll take notes about how student projects are going, which those are a bit sensitive. I shouldn't be showing you guys this stuff, maybe, but some of that. But yeah, it's basically useful to stay organized because it's really easy to lose track of things once you start getting into bigger projects or having a lot going on. I guess in the spirit of showing off sort of professional tools as well is paper writing is a big part of astronomical research. This is a paper. This is my next paper, I suppose, which is 39 pages. Oh God. But just about all astronomical papers are written in a markup language called LaTeX, and so this is a particular LaTeX package. I think it's part of the MacTeX distribution,
Yeah,
but yeah,
Mac has the
yeah,
MacTech and Linux has Tech Live. I don't know
yeah,
about the Windows. Yes.
yeah. There's a couple of different versions of different things out there as well, but
But there is an online version also, like Overleap. You don't
yeah,
have to
yeah.
download any software.
So yeah, I actually have Overleap. This is my other next paper. This is a paper that a student of mine is writing, and I'm working on as
Oh,
well.
he's a PhD or
No,
student.
undergraduate student. He was
Okay.
we worked together for a summer project, and it turned out really well actually. And so Overleap is nice because it's basically LaTeX in an online environment. So you can share the file. You can have multiple people typing at the same time, working on things. Some amount of version control and stuff like that. And so it's Overleaf is very nice when you're working with people, or if you want like a cloud backup of something, or if you want to work on it on different computers, and then something like a Mac Tech or like a local install is nice if you just want to sit and work on your own machine and not have to fuss about internet or online access. And so something went wrong. Okay, it's usually more reliable, but yeah. So getting involved in research does tend to involve some getting familiar with LaTeX. And I just found a typo. This should be a capital C. There we go. There we go. I am writing papers in real time. This is not. I don't know if this is the entertainment you were looking for, but
To be
yeah,
honest, this is the stuff which interests me. Might
sure.
be weird.
No, that's fine. So yeah, so this is a much shorter paper, a 9-page paper that we will probably finish up in January or February, I think, and hopefully submit. But yeah,
What's
this
the
was just
title?
a.
Can I see that?
Yeah, I guess it's fine to show it. I mean, this is a very niche subject. This is a project that I had sort of had an idea on a while back of, there's this problem that we deal with in data called bandwidth depolarization. And I had an idea about, hey, can I come up with a method that would try to correct for this problem in some data sets? And I had an idea, and I recruited a summer student, Max, and we wrote some simulations, and we tried some different algorithms to see what would work. And I sat down and I did some derivations that were not necessarily a whole lot of fun. Oops, that's the wrong zoom. But yeah, this equation was the bane of my life for at least a couple of weeks, trying to figure out what to do with this. But it's not that messy. At least the integral has a closed form solution, so I can't really complain.
Yeah. At least
But
you didn't have to do it numerically.
yeah, I mean, we ended up implementing numeric integration because it ended up being less work at certain stages. But yeah, so we came up. I developed some algorithms. I gave them to my student to test, and he implemented the algorithms and wrote some simulations. We tried some things, and we got some results that we think are interesting. And so we're gonna get this published, and we're gonna release the code to do this particular data correction if anyone's interested. It's kind of an obscure problem, so there aren't a lot of data sets affected by it. But if there's a couple of people
Also,
that
like,
find it
what's the
useful, then
like I am like in the early stages of my undergrad, like haven't started my first year, but what are the prerequisites to like do something like this in undergrad? Like I'm like really into research and all and want to publish a paper in
Mhm.
undergrad.
So yeah, the prerequisites are, I mean, basically having done enough coursework to understand the concepts for whatever the project is. And so in this case, this was a project that we did. The student had just finished his second year of undergrad, and so at that point he was familiar with coding, he's familiar with Python. He didn't know radio astronomy, but that was fine. I could teach the relevant sections of radio astronomy and radio polarization. Um, and that was basically all we needed going in. And I think it's hard for me to give definitive advice because it changes a lot by what country you're in. And so you're in India, I think, right? So I don't know the system there.
Yeah, yeah.
So yeah, like for example, in Canada, the system here is that the academic year runs for 8 months, and then there's a 4-month summer break. And there are a lot of programs for students to do research during that 4-month summer break. Um, and so it's 4 months of full-time employment as a research astronomer with
Okay.
some supervisor who has a project in mind, basically.
Okay, so in my
Generally.
university also we have something like this. Like
Mhm.
in the semester break or the year break, we do a project. But that's
Yeah,
voluntary, but most people do it. So it's kind of
yeah,
necessary.
yeah. It's a really good way to get experience. I mean, the other thing that we do here is there's an undergraduate research course, like an undergraduate thesis, which is I don't know if all students are required to do it, but a lot of them do. for the honors
Do they
program, I
take
guess.
like international students? Like, if I apply as an undergrad, that like, is this only for those who are Canadians?
So the summer programs are only for Canadian students, and the reason for that is because it ends up being too much paperwork to deal with visas for international students for a 4-month program.
Yeah, understandable, to be honest.
Is essentially, and I think I feel like I've heard that some American programs will accept international students, but I don't know the details about those. And so the summer program is normally in person. I guess to answer Safe Practices question, it's normally in person. The last 2 summers we've been doing remote, and so I actually did hire a student from the other side of Canada for the summer, and he didn't have to move. But there are also complicated legal issues with paying people in other countries, and so the university also doesn't want to deal with that. Is my impression. And it's so it basically comes down to, for a 4-month student project, it's not worth the paperwork of something involving visas and passports and international banking. Essentially, it's the sad truth, unfortunately.
Yeah, yeah, yeah. Understandable, to be honest. But
Um,
there are like I know like STSI conducts a undergrad research program.
mhm. Yeah, pretty much any research institute will have some kind of undergraduate experience program, I think, and um, yeah, I mean, getting in contact with researchers is a big help to that. Different places have different levels of organization. So I mean, I'm at a big university with a huge astronomy department, and so we actually run a proper program with a website and a list of research projects and stuff. But most smaller departments with fewer astronomers, it'll just be a couple of professors, and you just have to go and ask them essentially if they're hiring and if they're interested in taking on a student, and so that can
Our
be the best
university has like
approach.
a solar physics group. Like it does like space weather and like magnetohydrodynamics and all. So I have planned to apply there.
Mhm.
I'm still
Yeah,
not
great.
sure like if they will take me as an undergrad or not, but I'll try certainly.
Yeah, I mean, all you can do is ask to see what opportunities they have for undergraduates, and so um, yeah, it's you don't know if you don't ask is essentially how it tends to go, and a lot of these things there just won't be information online. You just have to send an email or something. I mean, to some degree, that's well, I was gonna say that's how I got started, but that's not true. I got recruited actually. I uh,
Okay.
I got recruited in the sense that I was taking a course and I was chatting with the professor and she asked me if I was interested in summer research. Um, so that's not the best example, I guess, but
You were certainly lucky because many people
yeah,
have to ask. Yeah.
yeah, yeah. I got very lucky in that respect. I That's definitely true. Um, yeah, let me see. Oh, I lost my notes. Where did I put my notes about anything else? Yeah. Oh, yeah. The only thing left on my list actually was, well, two things, I guess, is having a nice reference manager is also very useful. And this is yet another area where I'm not as organized as I'd like to be. But so yeah, I use a software called Mendeley, and there's a couple of different free. This is free. There's a couple of other ones, and it's basically just a program that keeps track of all of your papers in one place that you've saved. And so rather than saving them manually into trying to sort them out, is this gives you basically a little database. And so I use this a lot when I want to check something in particular papers. And so what's the one I look at most often is, where is it here? It's not alphabetized it properly. Yeah, Brenchings into 2005. I am always referencing this paper for like whenever I'm for a lot of different things that I work on. This is a very mathematical paper relevant to my niche field, but then basically the nice thing about this program is it saves the PDF for you and gives you a PDF viewer really quickly. And it also, it's really nice if you want to mark things up. Like, what's a good example of one that I've marked up? This one. Why do I have two copies of the same paper? This is me being disorganized. But yeah, so I mean, this was a paper where I went through and I deliberately took, put in some highlights and some notes and stuff, and sort of things that caught my attention. I just, this was my one day
I
where I was
haven't
trying to be
played
very.
played with this one very much, but I think like there's a citation manager also like it keeps track of the citations which you do. I
Yeah,
think.
yeah, yeah. So I mean, this one, I think it has the ability to. You can copy like Bibtex entries and stuff if you want to cite things in LaTeX, and so it gives you the very easy ability to. So yeah, like for this one, I could copy a Bibtex entry, and then I technically have a LaTeX uh, manager as well for my Bibtex files, but I could so I can just paste in the LaTeX entry, and now I have the same paper now in my Bibtex file.
What's
So
this like? What is this like software
uh,
references?
so this is something called Bibdesk. It's bundled with a MacTech package, and it's basically Mendeley but without the PDF viewer or without the PDF files. I guess it's only tracking the citation information. And so for each
Interesting.
paper, it knows the authors and the journal and stuff, and then it basically it outputs a Bibtex file, which then provides all of the information that LaTeX needs to generate. Where in this file where are the references? They're not at the end. Oh yeah, they are at the end. So basically everything it needs to produce a formatted reference list exists in the underlying file that this program is running or is opened. And
Okay, so
so
it's
I
different
use
for each file.
I use Mendeley nominally as my central database of papers, and then when I make a paper, I will have a new um, bibliography file, and I can basically copy and paste in just the papers that are relevant to what I'm citing in this paper, in principle. And so yeah, one is specific to the paper, and one is just my general archive. So although I'm not as organized as I'd like to be. Because part of the reason I'm not as organized is if you go onto the ADS, if you know what paper you're searching for, it also gives you the ability to get a Bibtex information on the paper, and you can just paste that in instead of going to Mendeley. And so yeah, I'm not as consistent about updating my Mendeley database as I should be, but whatever, it works. Um, yeah, and I think I don't really need to talk about it, but GitHub has been fantastically useful as well, just for organizing software and stuff, and particularly like I'm involved in some big software projects where I'm maintaining software that other people are using. But even for just keeping your own software in one place with some version control, learning to use Git and GitHub is a super useful thing. So Safe Practices asked about, do I submit background calculations? No, not really. And so typically the referees for the paper don't see anything that's outside of the paper. And so what's a good example actually? So in the case of, like, for example, this one with my student here, do we have we don't even have an appendix on this paper. So it's literally just the paper contents. And I think I don't know if we put this in yet. So I actually have a footnote in here. Where's the zoom button here? So in this case, this is sort of a special example. I've said that, hey, so I've put the code online, and so the code, if the referee wants to look at the code or play with it, I've put the particular code in some particular GitHub branch at some particular address. And so I put in that footnote explicitly for the referee, and then once the refereeing is done, I'm going to change that footnote to point readers of the final paper to the the correct web page as well, where they can get the code. Because part of this paper is sharing a code tool that we want people to have access to. In most papers, that's not part of the paper. And so, for example, if I go back to, this was my paper from earlier this year. This paper, I do not share any of the code or anything. I just, I have the flowcharts that describe what the code does, but the code itself is not shared. It's not accessible. And in the case of this paper, the code is a complete mess. So I'm quite happy that no human being ever looked at it. But yeah, I mean, wow. When I say I took 2 weeks on the calculations, it was 2 weeks to work out the derivation, and the derivation is in the paper. So in principle, it's possible for the referee to read through the paper, and in principle, if they want, they could redo every step of the derivation, and it shouldn't take them nearly as long because I have described what the steps are. And so that is necessary. In a paper where you do derive something, you have to show enough of the derivation that people can follow the steps is required. And so, yeah, it's
Also,
individual calculation.
yeah, continue. Like
No,
I'll
I was just going to say individual calculations tend not to get shown, but it's generally expected that a paper contains enough information that someone knows how you've calculated something and could reproduce it. People are not always very good about achieving that standard in some cases, but error bars are the worst. People will never describe their error analysis properly, and that pisses me off because I care a lot about error analysis.
Yeah, certainly. Because in the like Simbad magnitude one which you showed, there you talked about the 14 distances they showed. Like this was
Yeah,
quite surprising to me that only one or two observations showed the error bars.
yeah,
Like why are they not showing it?
uh,
Because
yeah.
it
I mean,
doesn't make sense if your error bar is like
yeah.
50% of your observation.
I mean, in some cases, it could be transcription problems. That Simbad, like the original paper, might have error bars, but Simbad wasn't able to transcribe them in properly for whatever reason. That's possible. Some projects simply don't report error bars if they're not sure how to estimate them. Some projects are just lazy and don't do error bars, and I don't approve. I just don't approve. Is a lot of people. I think maybe part of it is in a lot of cases people will report quantities without thinking a whole lot about how people are going to use them. In the sense that you report a quantity that you calculate, but it's not an important part of your paper, so you just do the calculation quickly, report the result, but you don't want to spend a lot of time doing the error analysis on it. And yet someone else, that is the most important thing they need, is that one number that you calculated. And so what's important for one person is not the same for another, and that can lead to mismatched expectations, I think.
Why the reason I'm pointing this out is because I was doing a project on like light curve analysis. So
Mhm.
there I referenced a paper which showed the data of the star and all, like mass, temperature and all. They didn't talk about error bars for certain quantities, but error bars for other quantities were mentioned. So it puts a wrong impression on a student, like is it not necessary and all.
Yeah, and that is a troubling thing in the sense that it should be necessary. It should be necessary as a matter of principle, but people can get away without doing it sometimes. And to some degree, it comes down to the paper referees calling them out to make if someone forgets, for example, or if someone decides it's too much work. Um, it's they shouldn't. In most cases, they shouldn't be allowed to get away with it. And I had a paper, or not a paper of mine. I found a paper that was relevant for something I was working on like last year, and that paper had no error bars, and I actually needed the error bars for my analysis. And so I was extraordinarily tempted to, when I wrote my paper on that, to write something about how we had to reject that data because it had no error bars. And I was tempted to write something really mean about it. And I don't think I did, because that's how you make enemies. But it's true that they published bad data, in the sense that they published something with no error bars, and now other people can't use it, and so it's kind of worthless, and it was a waste of effort on their part. And yeah, but people make mistakes, and so it's not like people are doing it on purpose. In some cases, or deliberately being bad about it.
Also, Cameron, you use Mathematica actively?
Not these days. So I learned Mathematica as an undergraduate. I took half a course on it, and I have not opened it ever since. Um,
I
it
mean,
doesn't.
I think the trend in astronomy is to use Python always.
Yeah, yeah. It depends on the group. Like I know some groups that do some stuff in Mathematica. It's kind of fallen out of favor, in the sense that I guess the question comes: what niche does it fill? In the sense that I mean, I don't do a whole lot of theory, and so like when I in the rare cases that I do have to sit down and do a derivation, I tend to do it just on paper myself, and I use Wolfram Alpha, which I guess is derived on Mathematica, but I tend to do things pen and paper when I need to, and yeah, I feel like most of the strength of Mathematica is in sort of the symbolic math. At least that's most of what I learned. Yes, that's just not a big part of my work.
Understandable.
MATLAB I've actually never learned. It wasn't part of any of the undergraduate curriculum where I studied. I mean, I do know other groups in it. I know it's quite popular in engineering, I think, in certain parts of physics. But it's just never come up in my own studies or my work. I vaguely remember I had to learn how to use Maple in my math classes as an undergrad. And I've never touched that since graduating those classes. So yeah, there's a lot of different solutions that each kind of have their own specialization, and there is some overlap in what they do, and so you can do a lot. You can do the same things with a lot of different tools. Um, one of my friends did his undergraduate research thesis as an Excel spreadsheet. He was doing a galaxy simulation, and he built an Excel spreadsheet to simulate galactic rotation, and it
Uh,
worked.
that okay worked.
It worked, yeah. I mean, he got a result. He got his undergraduate thesis. He graduated, and then the result was, I don't think it was published, but it answered the scientific question that he was trying to answer. So yeah, I mean, whatever
Interesting.
works is acceptable generally. Uh, yeah, I'm trying to think. Do I have anything else interesting I can show off? I don't know. Don't want to go digging through my old files for anything relevant, but any useful demonstrations? I'm not sure. Oh, what's this? I have some old data. Is this interesting? Do I have it? Oh, is the data actually here? Maybe not.
Also, Cameron, as a general advice, I want, like, is it advisable for undergrads to do reproduce some work which is already been done in a research paper?
Do you mean like as an independent project, like by
Yeah,
yourself?
yeah, yeah, yeah.
Um, yeah, I suppose so. I think that it's something that you can potentially point to, when you're if you're trying to convince a professor or a researcher to take you on as a student for a project. I think that's something you can point to say, hey, I already have some interest and some background, and I've been developing these skills. So I think there's value insofar as that goes, and there is value in terms of personal skill development as well. Yeah. So if the best way to master a subject is to do work interacting with that thing, and so if there's some specific thing that you want to become more knowledgeable about, then taking some time and picking some particular thing that sounds interesting and trying to reproduce it is certainly a good way to get closer to understanding the system, or understanding whatever it is that you want to learn about.
Because the reason I asked is because I think there is a really strong gatekeeping which happens, like if people not considering your work as legit or not. You see what I mean?
Well, a little bit maybe. I guess. Wow. I guess what I would say is I don't think there would be a lot of value in the sense of reproducing some work and then trying to publish it. Um,
Skill development, I would say, like
yeah, yeah.
learning
I mean,
something and learning about the topic.
doing it as a matter of personal interest and skill development, absolutely. And yeah, and gaining knowledge, I think. But yeah, so the gatekeeping thing, that's a complicated question in the sense that uh, I mean, modern research, particularly like research that is up to date and contributing to what we already know, like adding to what we already know, it does take so much knowledge about what's already been done, and knowledge about how to do things well without creating problems, like creating data artifacts, as we mentioned, or using methods that can introduce biases and things like that. There's so much of that it's hard for a person to get started independently. Right? I mean, this is something that I've talked to people about occasionally. People, they want to get involved, they want to start their own research project or research a thing that interests them, and then with the ultimate goal of contributing a paper or something, adding to knowledge. But doing so independently from scratch is difficult, because there are so many pitfalls, I think, and so the gatekeeping, I think, tends to emerge from that, in the sense that there are people who go out and put out ridiculous results, or crackpots in particular, people who have come up with their new theory of gravity, or their new proof about why quantum physics is wrong. That's a whole separate category. But
I hadn't talked about
um,
that.
yeah. But I mean, there's so much of that noise out there that people don't want to waste their time, and so there has become this sort of a big part of scientific writing has become, I guess, coding, in the sense of you are demonstrating that you are following the rules. Like when you write a paper following a certain style, and you say things a certain way, and things like, you format it in Latex, and all of these things, you're following the rules to show that you are working within the system of how people expect things to work. And that, so that is definitely gatekeeping, in the sense that if you don't follow those rules, like if you did a paper and you wrote it up in Microsoft Word, people would be like, is this serious research?
Yeah, yeah.
And
Like
it could be, but
it even shows
people.
like I have biases. Like when you talked about the that your friend of yours, like who did his project in Excel.
Yeah,
Yeah,
right. We're quick to laugh at that, because we don't think of Excel
yeah.
as as a computing environment or a computing
Now I
tool.
feel bad, but okay.
Yeah, and so it's yeah, and so there are these things, and these are all shortcuts we take to try and judge the quality of a work. When if we see a scientific work or something, or trying to assess whether a person is trustworthy as a scientist kind of thing. We make all of these decisions based on all of these metrics that aren't always fair, and it's not great, but it is. It kind of comes down to just saving time, because research. The amazing / frustrating things about research is that there is infinite amount of work to do. There's no limit to the amount of things that a researcher would like to do if they had infinite time. And so we are intensely jealous of guarding anything that wastes our time, I think. And that's not always a good
That's
thing.
certainly an interesting point.
Like, yeah, my to-do list in the last 5 years, my to-do list has never gotten shorter. It has only ever gotten longer. Except
That's
when
a
I
good
give
thing.
up on things. Yeah.
That's a good thing, actually.
I mean, it's good and it's bad. It's stressful in the sense that I can never finish something and say, yes, I have done enough. I can take a break now. I mean, I do take breaks, but not because I'm done, but because I have to be sane. But yeah, it's a mindset that can be unhealthy, but you have to work in such a way that you can deal with it.
And there's a whole another mess of publish or perish.
Oh yeah. I faced enough of that already too. Is yeah. I mean that's something that you don't have to worry about yet for sure. I mean it's not necessary for an undergraduate student to publish in order to move on to grad school. Well, I mean, I can't say that's necessarily true for everywhere, but in general, in North America and in Europe, it's not a requirement.
No, I mean, I really want to contribute to science and all. And I think a good way to start is, even if I don't get a publication, but I want to do some original work in my
Yeah,
undergrad.
yeah. No, and I mean, to some degree, that is actually necessary. I think for admission to most graduate programs, you have to demonstrate that you can do research, and the easiest way to demonstrate you can do research is by having done research. And so, yeah, I mean, most
The
graduate
curriculum
admission.
in which I am in, I'll do integrated bachelor's and master's, and then move on to PhD.
Okay, yeah, that helps. Um, so yeah, I mean, particularly the master's portion will get you that experience for sure. But yeah, I mean,
Yeah, there's a
the
one
sooner you
year
start, so,
research
yeah,
project.
yeah, yeah. I've seen those. I've seen those kinds of programs. They're usually quite good. Um, but yeah, I mean, the earlier you get started, the better it will go. Is a general rule. So yeah, there's different ways of doing it. Like in the sense that you can try different projects early on. Like do one project and then decide if you like it, and then try something a little bit different, and that lets you broaden your knowledge and your skill base a bit, and try and find something you like. Or another option is to spend a lot of time, you know, getting specialized in a subject, so that the point is that when you do reach your final research project, you're able to do a much better job of it, or take it further, or are more likely to produce a publishable paper. And so, I mean, that's just what I did as an undergrad. Is I worked on the same project for 2.5 years, I think, as an undergraduate. I was lucky
What was
enough
that?
to.
What project was that?
So it was a project where I was reducing data from the very large array, and then doing some modeling on it. I can actually pull it up. So I still have the search open here on EDS. So yeah, Cameron Vanek, 2011, Astrophysical Journal. Um, I can pull up the PDF, but so yeah, this was a 2-year project. I started as it was like 2 summers plus an 8-month student thesis, and yeah, so we had some VLA data, some observations, which I processed in apes, which was painful. That was an experience, and then I wrote some. I wasn't doing Python, so that the research group I was in at that time was using IDL as a programming language, and so I wrote a bunch of code in IDL to analyze the data and produce figures and stuff. and to make the catalog. And so yeah,
Interesting.
I produced a catalog of rotation measure results. And that was the first half of the paper, and then I had a couple of extra months after. I had a couple of months after my research thesis, but before my master's, and so we did a little bit of extra work in terms of modeling, creating some models of. In this case, it was the magnetic field in the disk of the Milky Way.
Okay, you
And
talked about this, I think. You have
yeah, I
talked
think
about this.
I may have mentioned it. Yeah, but so yeah, I spent a couple of months doing some modeling work, and that went into the paper as well. And so yeah, this paper, it wasn't published until I started my master's, but the work was all when I was an undergraduate student, and so it was a lot of work. But yeah, it was yeah, two and a half years, and yeah, catalog at the end.
It certainly looks good with all the plots and all.
Yeah, I mean, one thing I did like about IDL as a programming language is it did produce some really nice plots. Compared to the default in Python, they were much nicer, I think. But as a programming language, it was very similar to Python, but you had to pay for it, and that immediately made it very unpopular with most people. So most people have stopped using it because why would you pay for a programming language like Python if Python is out there? So, uh, but it was very easy
Also,
for me to
Cameron,
switch
if
to
you're
Python.
free, I'll send you the project. Hmm? I think like we are done now, right?
Yep, yep, that's fine. Um,
Okay.
but yeah, I mean, I'm happy to keep chatting, I guess, if there's anything else. Yep, my pleasure.